Okay, so we're going to start trigonometry in this video. Basically, trigonometry is the study of triangles, but we're going to look at two different types of triangles. So we right-angled triangles and then non-right-angled triangles. So the Leaving Cert Ordinary Level course deals with both. Okay, but this video we're mostly going to focus on right-angled triangles. So in our right angle triangle, obviously what you're looking for is our 90-degree angle. Okay, when we have a right angle triangle, we are using either Pythagoras theorem or we are using the trigonometric ratios sine, cos and tan. Okay, in non-right angle triangles, so obviously what you're looking for here is a triangle that clearly doesn't have a right angle. So it will be marked if it is a right angle, or it will say it. So for a non-right angle triangle, you're using the sine rule, the cosine rule, and the area of a triangle. Okay, this video we're just going to look at right angle triangles, and we'll move on to non-right angle triangles later. So for Pythagoras, this can only be used in right angle triangles. I've said that already. Right angle triangles only. Okay, so we've our right angle triangle, and the first thing you need to know is that the side directly across from that right angle is always the hypotenuse, and the hypotenuse is the longest side in the triangle. Okay, so our Pythagoras theorem is c squared equals a squared plus b squared. Okay, and this c is the length of the hypotenuse. Okay, so it's the hypotenuse squared equals the sum of the other two sides to be squared. So what we're looking at here is finding the missing side of a right angle triangle, and you're going to be given the other two sides. So you're not always going to be trying to find the hypotenuse. You might have to manipulate the formula a little bit, but the objective here is that you have a right angle triangle, you're given the length of two sides, and you're trying to find the third missing side, and you're going to use Pythagoras to do that. Okay, so we'll go on and do some examples. It's very straightforward. Make sure your calculator for trigonometry, you're going to use it so much, especially when we move on to trigonometric ratios. So first example here, we have a right angle triangle. We have the length 5, the length 12 and x, and we're obviously trying to find what x is here. So the first thing I would do is note that directly across from the right angle is the side of the hypotenuse. Okay, formula is c squared equals a squared plus b squared. And all we're doing is using substitution again, which we keep coming back to, which was the very first thing we did in algebra. We're going to replace the variables or the letters with the numbers in the question. Now, if this is C, it doesn't matter which side is A or B. So it doesn't matter here which one you sub into A or B, but it does matter that C here is X. So we've x squared equals 5 squared plus 12 squared. X squared equals 5 5s is 25, 12 12s is 144. X squared is equal to 25 plus 144 is 169. Remember, when you have something squared and you move it to the other side, it becomes the opposite operation. And the opposite operation to squared is the square root. Okay? And the square root means what number multiplied by itself would give me 169. Now you could just be using your calculator for stuff like this, but it's 13. So square root of 169, when you press equals, it gives you 13, because 13 times 13 is 169. So that is going to be 13 centimeters. Okay, or whatever the units were. It didn't actually say centimeters. Okay, so that's your first example. So there's two different ways you're going to be able to use Pythagoras. So this is the first way where you're trying to find the hypotenuse. And the next example, you're not trying to find the hypotenuse, you're trying to find one of the other sides. So as I said, we have a right angle triangle. Directly across from the right angle, we have our hypotenuse. Formula is c squared equals a squared plus b squared, and remember c is going to be the hypotenuse. So we've 17 squared on the left. Remember I said it didn't matter which one is a or b, so I'm going to sub in 15 for a, so 15 squared plus x squared, which is what we're trying to find here. Now what you're going to do, I generally multiply them out first of all, but you don't have to. You can put all of this into the calculator if you move the 15 over. So 17 squared is 289, and 15 squared is 225 plus x squared. So now we just have an algebraic equation. I'm going to leave 289 on the left, and I'm going to bring plus 225 over to the other side. And if we were adding on the right hand side, it means we are subtracting on the left hand side. And what we now have is 289 minus 225 equals x squared. Okay, so we're left with 64 on the left equals x squared. And remember, if we are trying to get x squared and moving it to the other side, that's going to become the square root of 64 equals x. And what number multiplies by itself to give 64 would be 8. So 8 here is this side. Okay, now keep in mind, I did say at the very start that the hypotenuse always has to be the longest side. Okay, so our answer here in the first one was for the hypotenuse. We had 5 and 12, so notice that 13, it had to be the longest side here. This example, this was not the hypotenuse, so it makes sense that 8 is not the longest side, but 17 here, the hypotenuse is the longest. So that's a good way to always check if you're correct, that it makes sense that the answer you found, if it's the hypotenuse, then it should always be the longest side. Okay. So moving on to trigonometric ratios. This is a lot of calculator work, so make sure you always have your calculator for this. What we're looking at here is sine, cos and tan. Okay, you have your three ratios. Sine of the angle is equal the opposite over the hypotenuse. Cos of the angle is equal to the adjacent over hypotenuse. And tan of the angle is equal to opposite over adjacent. Now that probably doesn't make any sense just yet. Okay, I'll talk you through on the triangles. So first thing again is we know the hypotenuse is always directly across from the right angle. I'm going to call this here angle A. Okay, because the adjacent and the opposite sides are dependent on where the angle is. So this is our hypotenuse. Other two sides we're looking for is the adjacent and the opposite. Well, the opposite, we know opposite means across. So opposite is going to be the side directly across from the angle in the question, which means that the third side here would be the adjacent, and adjacent means beside the angle. Okay, so hypotenuse is always going to be directly across from the right angle. The opposite is going to be across from the angle in the question, And the third side is the adjacent, and adjacent means beside the angle. Okay, and I'm just going to show you another example of that, but I'm going to change the location of the angle in the question. So I'm going to call this angle B up at the top of that triangle. Directly across from the right angle, we always have the hypotenuse. Okay, this time the side across from B is the opposite. So you should now notice that the opposite is in different places because the angle in the question is in a different place. Okay, so that means that this side here must be the adjacent. Okay, and that's beside the angle B. So there are the two ways you're going to see this in these questions. There's going to be different types of questions here. So first of all, we're going to look at finding the missing side using sine, cos and tan. And then later we look at finding the missing angles using sine, cos and tan. So sine of the angle is when we have the opposite and the hypotenuse. Cos of the angle is when we have the adjacent and the hypotenuse in the question. And tan of the angle is when we have the opposite and the adjacent. So we say to the lads, soca toa, to remember. Okay. So sine, opposite hypotenuse, cos, adjacent hypotenuse, tan, opposite adjacent. So the best thing we can do here is to go through examples, because in theory it probably seems a little bit more complicated than it is. So example 1, we are given our right angle triangle. Okay, remember you're only using this if you have a right angle triangle. You can't use it if it's not a right angle triangle. So we've right angle triangle A, B and C. These are the vertices. Just a little bit of geometry as well. So the vertices are the corners of the triangle. Okay, just in case you see the word vertex is singular and vertices is the corners of the shape. So we've A, B and C are the corners here. Doesn't really matter, only for we refer to it in the name. This is a 35-degree angle here. The hypotenuse I can see here is 8. And it's saying find the length of BC. And you can see that's the length of this side here. Now, the first thing I do is label the side that they're looking for. And I'm going to call it X. We mostly use X's. So I'm going to call that X there. The side we're looking for is BC. Next thing, we're going to label what sides we have in the question. Do we have a hypotenuse value? Do we have opposite? Do we have adjacent? Or what side are we trying to find? So I have the hypotenuse here given in the question, and the side that I'm trying to find in relation to the angle is the opposite. Okay, so I need to decide now, looking at soca toa, or looking at sine, cos and tan, I need to decide what ratio am I using if it's hypotenuse and opposite. And if I look up here, opposite and hypotenuse means we're using sine. So the first thing I would write down is sine is equal to opposite over hypotenuse, to show that you've picked the correct ratio first of all. So what we do is sub in the information. So we've sine, the angle in the question was 35. So it's sine of 35 equals the opposite here is X, which I'm trying to find, over the hypotenuse here is 8. Okay, now if I'm trying to solve for X, it means I need to get X on its own. So I'm going to move this 8 over to the other side. And remember, if we're dividing by something on one side and we move it over, then we are multiplying on the other side, and you can just write it in front of the sine of 35. So it'll be like using brackets here. 8 times sine of 35. We go to our calculator and we press 8 sine of 35 equals 4 so x is equal to 4.588 dot dot dot. Okay, and it says give your answer to one decimal place. Now one decimal place means we only want one digit after the decimal point, so I need to look at the second digit. If it's 5 or greater, we round the previous digit up. If it's less than 5, then this 5 would stay the same. So because 8 is greater than 5, we have 4.6 is the length of that side x. Just a note on the calculator. Where's my other one? Yeah. So if we have to check our calculator, we need to go to shift mode and make sure it's in degree mode, so 3, and there should be a D at the top if it's a Casio calculator. And then here, this one is degrees already, yeah. So on the sharp calculator, you're looking for a D or a G button, and you can see it changes at the top. It should say DEG for degrees or AD for radians. So you need to make sure it's on degrees when you're using your calculator for trigonometry. Okay, otherwise it will give you the wrong answer. So just be careful with that. Let's look at another example. We have two right angle triangles back to back here. Okay, and it says find x and y corrected 2 decimal places. So I'm going to treat these as two separate triangles, but you're going to need to find one of them in order to be able to find the other one. So there is one that you'll need to find first. Okay. So what we have here is trying to find x and y. Now if I cover this triangle here, what I'll notice is I don't have enough information to find y. Okay, this is x, this is y. I would need one more piece of information on this triangle if I was to start with this one. So I'm going to start with the triangle on the left hand side, and I often draw it out again just so I'm ignoring all that other information that I don't need. We've 40 degrees, we've 8 and we've x, and this is A, B and C. Now remember, what we're going to do first is label the information we have. So we have the hypotenuse, okay, and again here we have the opposite. Okay, so it's always in relation to the angle in the question. Now we have SOHCAHTOA as our way of remembering our trigonometric ratios. So what we're looking at here is the opposite and the hypotenuse. So again, I can see I'm using sine. So we've sine of the angle, so sine 40 equals opposite here is x over the hypotenuse is 8. We're trying to solve for x here, so we need to move the 8 over. So it's 8 sine of 40 is equal to x. On our calculators, 8 sine of 40, and it gives me 5.1423 dot dot dot. It said give your answer corrected 2 decimal places. So that means it wants 2 digits after the decimal point. So I need to look at the third digit. Because it's less than 5, it doesn't affect the answer. So your answer here is 5.14. Okay, now keep in mind here, we are not finished the question because we need to find y. So I'm going to draw that other triangle. This here was y. The angle at the top was 60. We have our right angle. And x was this length here. But we now know that x is 5.14. So I'm redrawing the picture, and now I'm including the information I found in part 1, which I wouldn't be able to find y unless I used 5.14 in this question. So let's label what we have here. Y is the hypotenuse, So we're using the hypotenuse. And then if you think about it, this is 60. So directly across from 60 would be the opposite side, but we don't have any information there. So I'm not writing down the opposite, which means beside the angle, or the last one left over, would be the adjacent. Okay. Now, if I look at my SOHCAHTOA, I'm now looking for either sine, cos, or tan, and I'm picking the ratio that has adjacent and hypotenuse in it. Okay, so I'm now using cos of the angle equals adjacent over hypotenuse. So we've cos of 60 equals, the adjacent is 5.14 and the hypotenuse here is y. Now, this is a little bit different to the previous two examples, because if you notice in the last two examples, the variable has been the numerator of the fraction, but now we've the variable as the denominator, so the variable's at the bottom. Now, if you're to think about what we did up here, the y would move over and become multiplication, so it's y cos of 60 equals 5.14. Now we're trying to find y on its own. So if I leave y on its own on the left, on the right I'd 5.14. This was y times cos of 60. So if I move cos of 60 to the other side, it's going to become division. Now if you go back up here and compare these two, you will see all that happened here was the cos of 60 and the y changed places. So you could technically leave out this line here and you could just change the y and the cos of 60, and that will always be the case if the y, or the variable, is the denominator. Okay, so you're going to change those two, and now we're just using our calculator. So 5.14 divided by cos of 60, and I got a fraction, so I need to press the change button. Okay, so 10.28 is the y value here. Okay, so a little bit more work with that one. Okay, so just be careful here when the variable is the denominator of the fraction. Okay, so moving on, we're now going to look at finding missing angles using sine, cos, and tan. Now, that means we are still very much using our SOHCAHTOA for each of these questions. We just use it a little bit differently when we're talking about angles. So, example 1, it says find the measure of angle A. Okay, very first step, which I've done in all of the other examples, is I'm writing down what sides I'm using in the question. So the hypotenuse is 61, directly across from the right angle, so I'm using the hypotenuse. And here across from the angle A we've 11, so we're using the opposite here again. So first thing I'm going to write down is sine of the angle is opposite over hypotenuse. So let's sub in what we have. The angle in the question is A. So I'm going to leave A there beside sine. The opposite here is 11 and the hypotenuse is 61. Okay, now we are trying to find A. So I need to leave A on its own. And when I move one of the trigonometric ratios over to the other side, on your calculator, you're pressing second function sine. So it becomes the inverse of sine. So when I move sine over, it becomes the inverse of sine, which is written as sine to the power of -1. Okay, and we've 11 over 61. Now to do the inverse on the calculator, If you have a sharp calculator, you're pressing second function and then the trigonometric ratio. For this question, it was sine. And if it's a Casio calculator, you're pressing the shift button and sine. So on my calculator, I'm pressing second function and I'm pressing sine, and you can see it comes up as the power of -1. Okay. And I'm going to put in brackets 11, and I'm actually just going to do divided by 61 because sometimes the fraction button doesn't pick it up fully correct depending on what calculator you have. So 11 divided by 61. So I have 10.3888. So the angle is 10.3888. And I'm just going to do to the nearest whole number. It didn't say. So I'm just going to do A is equal to 10 degrees. Okay, so the only difference here is that we're trying to find the angle. When we move the trigonometric ratio to the other side, it becomes the inverse of sine, cos, or tan. So we need to press the second function button or the shift button to make it the inverse. Let's do another example. Find to the nearest degree the measure of angle B in both of these triangles. Okay. First step, across from B, we have the opposite side. And then we don't have the hypotenuse, but beside B, we have the adjacent. So if I look at SOHCAHTOA again, opposite and adjacent is tan. So we've tan of the angle B is equal to the opposite, which is 4, over the adjacent, which is 7. Now remember, I'm leaving B on the left because that's what I'm trying to find. When I bring tan over, it becomes the inverse of tan, 4 over 7. So I'm going to my calculator, second function, tan. You can see they have the power of -1 there. I always open a bracket just to be careful on the calculator. 4 divided by 7. Closing my bracket. I have 29.744. So B is equal to 29.744. And again, I'm going to do nearest whole number. So the 7 is going to round the 29 up to 30. So B is equal to 30 degrees. Okay. Next example, my first step again. We have labeling the sides. So first thing I can see here in this question is we have the hypotenuse. We don't have the opposite. So we have the adjacent here. We've adjacent and hypotenuse. So if we look at SOHCAHTOA, it's going to be cos of the angle. So cos of B is equal to the adjacent is 13 over the hypotenuse is 17. Leaving B on the left, and when we bring cos over, it becomes the inverse. So on our calculator, second function cos, 13 divided by 17. Because I didn't put the bracket in, so sorry, second function cos, bracket 13 divided by 17. So we 40.11. So B is equal to 40.11 ... And because the 1 here is less than 5, it's just B equals 40 degrees. Okay, so finding the missing angles, we're using the inverse of sine, cos, and tan. Okay, and the last thing we're just going to talk about here is the angles of elevation and the angles of depression. So elevation means to go up and depression means to be down. So what we're looking at here is an angle of elevation is an angle above the horizontal. So let's look at this in a picture. we have a right angle triangle. Okay, and what we're looking at here is if there was a person standing down here, I can't draw, and they were looking up at something up here. The angle of elevation is the angle that is formed with the horizontal line and looking upwards. So this here would be the angle of elevation. Okay. Now let's look at the angle of depression. So we are now going to draw our right angle triangle. Okay. The person is now standing up here. Okay. And say they're looking down here at a boat. The angle of depression is the angle when the person is looking down, but it's the angle that's formed with the horizontal. So it's not this angle in here, it's the angle that's formed with the horizontal that the person is looking down from. Okay, now the only reason you need to know both of these is that in a question they might say to you, and they mightn't put it on a picture, they might say the angle of elevation is 45 degrees. So you need to be able to sketch your triangle and figure out where the angle of elevation or depression is in order to use either Pythagoras, sine, cos or tan, finding missing sides or angles, whatever it is. Okay, so that's more understanding what they are, as opposed to kind of being questioned on them specifically. Okay, it's more understanding where the angle of elevation or depression is. Okay, so we're going to leave that video there, and I'm going to send on these examples. A lot in that, so make sure you go through it slowly and carefully and make sure you understand it all, because it's really, really important.